Hello everyone, I'm Ryan Chan, the CEO and founder of UpKeep. Today we're going to delve deep into the world of pressure sensors, where we'll journey from their humble beginnings in the 1590s to the cutting-edge devices we use today. We'll explain what a pressure sensor is, how it works, and the crucial role they play in specialized maintenance strategies. We'll also discuss their various types and applications in different industries, and how they can save your business time and money. So, stay tuned to learn more about these fascinating devices and their impact on maintenance and reliability teams. Let's take a journey back in time, all the way to the 1590s. People were fascinated with measuring pressure changes, and the first attempts at describing these fluctuations began with simple glass tubes and barometer experiments. These instruments measured how much the fluid inside them was pushed or pulled by pressure changes. Fast forward 500 years to today, and we've come a long way from measuring the rise and fall of fluids in tubes. We now understand the effects of pressure changes on the physical and electrical properties of materials. Thanks to highly advanced pressure sensors, it's easy to measure pressure fluctuations with astounding precision and accuracy. So what exactly is a pressure sensor? Well, it's a device that senses and measures pressure, which is defined as the amount of force exerted over an area. Pressure sensors play a crucial role in specialized maintenance strategies, like predictive maintenance. They collect real-time data on the conditions of equipment, and based on this information, they can predict and prepare for failure patterns. Imagine installing pressure sensors to certain tanks and other pressurized assets. These sensors can alert maintenance teams when the pressure falls outside of a specified level, allowing them to address the issue immediately. A typical example of a pressure sensor in maintenance is a transducer that picks up a signal when pressure is applied to it. But how do these pressure sensors work? It's all about measuring a physical change that happens as a reaction to pressure differences. After measuring these physical changes, the information is converted into electric signals. These signals can then be displayed as usable data that the team can interpret. Let's break down this process. First, a strain gauge converts pressure to electrical signals. This is a mechanical apparatus that allows small expansions and contractions as pressure is applied or relieved. The sensor measures and calibrates these physical deformations to show how much pressure is put on a piece of equipment or tank, then converts these changes into voltages or electric signals. Next, these electric signals are measured and recorded. Once the sensor produces an electrical signal, the device can record a pressure reading. These signals increase or decrease in intensity depending on the pressure felt by the sensor. Depending on the signal frequency, pressure readings can be performed between very close time intervals. Then, your CMMS receives an electric signal. The electrical signals are now in the form of a pressure reading, in units such as pounds per square inch or pascals. The sensors send out the readings, which are then received by your CMMS in real time. With multiple sensors installed throughout various assets, a CMMS system acts as the central hub to keep track of the whole facility. Finally, your CMMS alerts maintenance teams. With sensors in place, your maintenance teams get alerted when a pressure measurement is too high or too low. Pressure ratings that are too high can indicate a risk of parts rupturing or a chance of damaged equipment. On the other hand, a loss of pressure can be a sign of leakage, especially on pressure vessels. Real-time data, combined with mobile functionality, give your team a view of the state of the facility at all times. Now let's talk about the 7 types of pressure sensors, which can be categorized according to the method they sense pressure changes. First, we have the strain gauge, which measures pressure by observing the proportional expansion or contraction of materials as an object applies force. Next, there's the piezoelectric sensor, which works by employing the piezoelectric effect, generating an electric charge as a response to physical changes to material. Then we have capacitive sensors, which measure the capacitance between two plates with values that vary with the surrounding pressure. Fourth, we have manometers, which use liquid movement to compare the pressure experienced by its two surfaces. Fifth, there's the vacuum pressure sensor, which observes and measures the effects on the properties of the materials in vacuum pressure levels. Sixth, we have the Bourdon tube, a mechanical device that uses physical movements to measure pressure. And last but not least, we have the aneroid barometer, a purely mechanical device used to measure pressure. commonly used in aircrafts to measure altitude based on changes in barometric pressure. With these various types of pressure sensors, a wide range of applications in your facility emerge. They can be used for pipeline or hydraulic hose pressure, setting norms for electronic transmitters, measuring low to high vacuum pressure, energy conservation applications, technology industry applications, and manufacturing applications. These pressure sensors can save your business time and money. Imagine having the power to look into the future and using that power to come up with a maintenance plan in time to prevent breakdowns from occurring. That's essentially what pressure sensors as tools in predictive maintenance are trying to do. In fact, the U.S. Department of Energy estimates roughly 8 to 12% savings over preventive maintenance and up to 40% savings over reactive maintenance. Think of these savings as an added bonus on top of huge safety benefits and increased reliability. Most modern facilities are dependent on equipment that use highly pressurized vessels. Equipment breakdown can cause catastrophic failures due to the high energy that they store. Pressure sensors help to identify risks early by notifying the maintenance teams of any anomalous deviations from ideal working conditions. Combined with a predictive maintenance strategy, sensors allow maintenance teams to perform corrective action before any failures occur. Thank you for joining us on this journey through the world of pressure sensors. We've covered their history, how they work, their various types, and their crucial role in predictive maintenance strategies. Remember, these devices can save your business time and money by alerting maintenance teams to potential issues before they become problems. If you found this video helpful, please subscribe to our channel for more informative content. For more resources and information, visit us at upkeep.com.